All right. Good morning, everybody. Um, we'll start in a few minutes. All right. Please, when you join the chat, just state your name in the chat for me, please. Right. I know Saeed is here already. Just type your name in the chat for me, please. Thank you. All right. So let me begin. Right. Okay, so what I'm gonna be doing today, I'm gonna be starting the review of organic chemistry, right? Now, as I keep saying in class, organic chemistry is one of those, it's a very easy topic that you can gain a lot of marks in, right? And the thing is, in some schools, they teach organic chemistry down to the end. But the thing is, down to the end, students are busy doing SBAs, so they don't spend much time on organic chemistry. But the thing is, at least 2 questions in your paper will be on organic chemistry. Now, I typically read the examiner reports to see what they're saying, and they complain that students continue to do poorly in this particular topic, right, or section of the syllabus, right? So what I'm going to do, I'm going to review basically what we need to know for organic chemistry, right? Now, the first thing, organic chemistry is essentially the chemistry of carbon compounds, right? Now, first thing we need to know what is meant by something called a functional group, right? So let's talk about this, something called a functional group, right? Now, in the exam, they can ask you, what is a functional group? A functional group is a group of atoms, that determine the chemical properties of an organic compound. Right? So if they ask you in the exam, what is a functional group? This is what we're going to tell them. Now, organic compounds are grouped, right, according to their chemical properties and according to their functional group. Now, the thing is, you all need to remember that the functional group, right, determines the chemical property, So my functional group is what determines my chemical property. Now, I'm going to show you some different types of organic compounds, and we're going to see what the functional group is, right? So, for example, organic compounds can be grouped according to alkanes. We're going to talk about this some more. We have something called alkenes. We have alcohols. We have carboxylic acids. Right? We have esters. Right? These are different categories of organic compounds. Right? Now, in the case of an alkene, I'm going to draw an example of what an alkene looks like. So an alkene may look like this. Now, what makes something an alkene is that we see single bonds present and we only have carbon and hydrogen present, right? So sometimes you're going to say, well, the functional group present in an alkene is this, right? In the case of an alkene now, so let me draw an alkene across here. An alkene is going to look something like this. Right? This is just an example I'm giving you here. So the functional group present in the alkene is this double bond here, right? This is what makes this an alkene, right? So in the exam, they can draw a structure for you and ask you, what is the functional group present? Let me show you what an alcohol looks like. So an alcohol looks like this. So this is what an alcohol group looks like. Alcohol, and the functional group that is present in the alcohol is this OH group. This is what makes it an alcohol, right? So what I'm circling here, these are what we call functional groups. Let's look at carboxylic acid. In the case of a carboxylic acid, it's going to look like this. Now, the functional group here in the carboxylic acid is this whole thing here. Right? So the first thing, if I were to give you a compound, you need to be able to tell me what is the functional group that is present. Alright? Now let's talk about something else one time. So I started off by saying organic compounds are grouped, right? And they are grouped to form what we call homologous series. Homologous series, right? So in the exam, they can ask you, what is a homologous series? So a homologous series is a group of organic compounds that have the same functional group similar chemical properties, because I indicated to you all that your functional group determines your chemical properties. So similar chemical properties and physical properties which vary with the number of carbon atoms. Right? So you need to be able to give a definition for a homologous series. So a homologous series is simply a group of organic compounds that have the same functional group, similar chemical properties, and physical properties which vary with the number of carbon atoms present. Right? So you all need to be able to give a definition for that. Now, the other thing that you all need to be able to give, they will ask you what are the properties of a homologous series. So the first thing, or the first property, is that in the definition we say that they have the same functional group, right? So all members of a homologous series have the same functional group. So they have the same functional group. Right? So because they have the same functional group, obviously they're going to have the same chemical properties. Right? So they're going to have the same chemical properties. Another thing that they have in common is that they have the same general formula. Right? They have the same general formula. I'll talk some more about this in a little bit. Right? So same chemical properties, same general formula. Adjacent members differ by CH2. Right? I'll explain some more what that means when I start a look at the homologous series for the alkanes and alkenes. Right? So same general formula, adjacent members differ by CH2, and you need to know about the physical properties. So like I said in the definition, physical properties vary with number of carbon atoms. Alright, so these are some of the properties of a homologous series. Please make sure you know them, because in the multiple choice exam they usually have a question related to this, right? But you need to read the answers properly, because for example, let's say adjacent members differ by CH2. They might tell you something that sounds like that. You just saw CH2 and you think, oh, that's part of the answer. You need to read your questions carefully, right? Now, let's see. So let me go to the general formula, right? Now, alkenes, they have a general formula. Their general formula is CnH2n plus 2, right? Now, what does that mean? It means that if I have, let's say, n equal 1, and this is carbon atoms, right? The formula for my first alkane will be this. C1H, you're going to substitute into the formula 2 by 1 plus 2, and this will give me CH4, right? Which is methane. Now, they can ask you to name or state the formula for the alkane that has 5 carbon atoms, right? So let's say n equal 5. So if n is equal to 5, the formula is going to be C5H2 by 5 plus 2, which will be C5H12, right? So that's how we use the general formula. If we know how many carbon atoms are present, we can write what the formula is. So that's the general formula for an alkane. The next one that you need to know is the alkene. So alkenes, that formula is CnH2n. Right? So the formula is different. Look at the names. One is an alkane, and one is an alkene. Right? And the general formula is different. Let's say for an alcohol, the formula is CnH2n plus 1 OH, right? Because remember what I showed you previously, in an alcohol, the functional group present is the OH group. So that's the general formula for an alcohol. For a carboxylic acid, formula is CnH2n plus 1 COOH, right? But when you're using this formula, you need to be careful, because if I tell you write the formula of a carboxylic acid that has 2 carbon atoms in it, I'm going to have to use n equal 1 into the formula, because if you look at this, look, you have a carbon here, right? So be careful when they ask you to write the formula for a carboxylic acid where they give us the number of carbon atoms, right? So if they want the formula for the carboxylic acid that has, let's say, 3 carbon atoms, then I'm going to have to use n equal 2, right? Because you already have a carbon present in the COOH, all right? So this is a general formula. You need to know that. Now, let me ask you some questions. Hold on, let me just copy some. Give me 1 second. Alright, so here's what I'm going to do, right? Just to make sure you know what we're talking about. I'm going to either give you the formula, or I'm either going to draw something for you, and you need to tell me what homologous series it belongs to. Alright, so the first one, I'm going to give you this compound here. So this compound looks like this. I want you all to tell me in the chat, what functional, sorry, not what functional group, what homologous series does this belong to, right? What homologous series does this belong to? Alright, so I'm hearing people saying alcohol, alcohol. That is correct. So this compound here is an alcohol. Right? So they can give you a diagram like this and they can say, hey, what homologous series does this belong to? That is correct. Now, if I give you something like this. So what homologous series does this belong to? Alright, so I'm seeing some answers. We have alkene, that is correct. So this is an alkene. Alright, so that compound is an alkene. Let me give you an next one. What about this? What type of compound is this? Alright, so I'm seeing alkanoic acid. That's correct. Or carboxylic acid. Now, so this is a carboxylic acid. right? Or sometimes you'll see alkanoic acid. That's also correct, right? So they can draw a diagram and they can ask you to tell them what functional or what homologous series does it belong to. Now, another way they can ask this question, right? They can give you the formula. So they can give you a formula like this. CH3, CH2, CH2, CH3. They can give you a formula like this. And they can ask you, what homologous series does this belong to? What can you say about that? Alright, I'm seeing some answers there. I'm seeing alkane. That is correct. Now, so they can give you a formula and they can ask you what group it belongs to. So this is an alkane. If you all are not sure what you could do, you can draw it out. CH3 is what I'm drawing here. The CH3. CH2 is this. We draw next CH2. And then we draw next CH3. Right? So if you look at the formula and you can't visualize what is happening, please draw it. Right? What if we have something like this? CH3, CH2, CH2, OH. What homologous series does this belong to? Alright, so I'm seeing everybody saying alcohol. That is correct. It is an alcohol, and the reason why it's an alcohol is because it has the OH group. If I have something like this now, what homologous series does this belong to? Alright, so I'm seeing alkanoic acid or carboxylic acid, right? So you all can actually say alkanoic acid or carboxylic acid, right? Any one of those terms that you use, you're going to get the marks, alright? So far you've looked at, if I give you a structure, you can tell me what homologous series you belong to. If I give you a formula, you need to be able to do the same thing. Alright? Now, let's talk about some names. Now, you all need to be able to name organic compounds, right? So for example, organic compounds usually have a prefix that we use, right? Now let's look at number of carbon atoms. So if we have one carbon atom, the prefix we're going to use is called met, METH, right? If we have two carbon atoms, we use ETH. If we have three carbon atoms, we're going to use prop. Four carbon atoms, we're going to use the prefix but. 5, we call that pent. And 6, we're going to call that hex, right? I mean, you could go much further, but just know these for now. So when we have one carbon atoms, we go with met. If it's 2, it's eth. 3 carbon atoms is prop. 4 carbon atoms, but. And 5 is pent. And 6 is hex. Now, what does that really mean? Now, if I have a compound like this, right? Let's say C2 H6, C2H6, right? This compound here, this organic compound, it has 2 carbon atoms, right? And it belongs to the alkene homologous series. So it's an alkene, right? It's an alkene, right? Because it follows the general formula CnH2n plus 2. That's an alkene, right? And the thing is, it has 2 carbon atoms. So if it has 2 carbon atoms, the prefix that we're going to use is ETH. So the name of this compound is going to be ETH or ethane, right? Let's say I have something like, let's say CH3, CH2, CH2OH, right? I have a compound like this. Because we have the OH group present, we know it's an alcohol, right? Now, because it's an alcohol, so check. The first thing we need to do, we need to see how many carbon atoms we have. We have 1, 2, 3 carbon atoms, right? So the prefix we're going to use is prop. So the name is going to start off with prop, right? And the thing is, because it's an alcohol, we're going to call it propanol, right? Now I'm going to talk some more about specifically naming these kinds of things, because we need to state the position where the OH is, alright? So this compound is actually called 1-propanol or propan-1-ol, right? We'll talk more about this when we come to alcohols. So make sure you all know the prefixes, right? While we go through some of the topics, I'll show you how to name some of these compounds, alright? So let's start talking about what we call hydrocarbons. Now in the exam, they can ask you what is meant or what is called a hydrocarbon, right? A hydrocarbon is an organic compound that contains carbon and hydrogen only. So these are hydrocarbons, right? Compounds that contain carbon and hydrogen only, right? Now the two, we need to be able to state where do we get hydrocarbons from, right? So a source of hydrocarbon is petroleum or crude oil, right? There's a little 1-mark question. Sometimes they ask in the exam. They can also ask you this in the multiple choice exam. Name a source of hydrocarbons. So hydrocarbons, we get that from petroleum or crude oil. Then there's also natural gas, which we use here in Trinidad. So natural gas, the main constituent, This is a multiple choice question. The main constituent of natural gas is methane, right? Or CH4. This is an exam question you need to know the answer to, right? So the main constituent of natural gas is methane. Now, I started off by saying hydrocarbons contain carbon and hydrogen only, right? So hydrocarbons that we're going to look at are alkanes and alkenes, right? These are two examples of hydrocarbons. So let's start talking about the alkane homologous series. So we have alkanes. So the members of the alkane homologous series. So the first member is going to look like this. So this is the first member of the alkane homologous series. Its formula is CH4 and its name is methane. Right? So we need to know that. That's the first member of the alkane homologous series. The next member, we're going to have two carbon atoms. So it's going to be this. So this formula is going to be C2H6, right? Now remember, the general formula for an alkane is CnH2n plus 2, right? You all need to know that. So the name of this one here is called ethane. Then the next one, three carbon atoms. And this formula is C3H8, and this is called propane. Right? So propane is what we use. Sometimes they ask you for uses. So methane is used to produce electricity. Right? We burn natural gas to boil water. The water produces steam. Steam turns turbines, and that's how we produce electricity. Right? In the case of propane, we use propane to cook. Right? So we use this as a cooking gas. Right? The member that comes after will have 4 carbon atoms. So this will be 1, 2, 3, 4. Right, so the formula in this case here will be C4H10, right? And the name of this, because we have 4 carbon atoms, the prefix is going to be but. So this is butane, right? And we use butane as a lighter fuel. And when you say lighter fuel, you know, people who smoke cigarette, they have a lighter, right? We use butane as a lighter fuel, right? And we can continue along the homologous series. Now, so we know the general formula. The general formula is CnH2n plus 2. I've shown you how the structures look. I've shown you what the formulas look like and some examples of their uses. I said I was going to come back and tell you, remember when I said one of the properties of a homologous series, the adjacent members differ by CH2? Look at something here. The difference between this and this, all we've done is added a CH2. The difference between this and this, all we've done is added another CH2, right? So adjacent members in a homologous series, they differ by CH2 units. That is what it means, right? So I've seen multiple choice questions where they say they all have the same same empirical formula or same something, right? Please read your questions carefully. Now, apart from drawing and writing the formulas, you all need to know the reactions of these organic compounds, right? Because when we do the reactions, they give you a lot of marks for these things, eh? So the first thing, let's go. So the reactions of alkanes. Right? So the first one, first reaction of alkanes, reaction with oxygen, right? So the reaction with oxygen. Now, for all these reactions, for all the organic compounds, you need to know exactly what happens. You need to be able to write an equation, and sometimes you need to remember the reaction conditions, because these are the things that they're looking for in order to give you a mark, right? Now, let's say, so when you burn an alkane and oxygen, my products are carbon dioxide and water, right? So basically, alkanes, they burn with a clean, so they burn with a clean blue flame. Right? So that is what alkanes do. They burn with a clean blue flame, right? So for example, let's give you an easy one. Let's say we have CH4, that's methane, plus O2 produces. Now the products will always, it'll always be CO2 gas and H2O liquid, right? It'll always be that. Now, the thing is, you need to be able to balance your equation. If we look at something here, we have one carbon, we have one carbon. You have 4 hydrogen, but you have 2 hydrogen here. So what I should do, I should put a 2 in front of this. So now let's check. So the carbon, they're balanced, the hydrogen are balanced. On this side, the left side, you have 2 oxygen, but on this side you have 2 and 2, you have 4. So basically, we need to put a 2 in front here. Alright? So please, in the exam, they can ask you to, they can give you any equation, right? And ask you to write an equation for the combustion of an alkane. So let's say we had something like C5H12 plus oxygen gas, right? Producing, we know it's going to produce CO2 gas plus H2O liquid. It's always going to produce those two things. Now the thing is, some students, when they get this, they find it hard to balance this equation. But the thing is, there is a technique that we can use in order to balance this equation, right? So let me show you how we balance this. So what I typically do, I try to balance the carbon and the hydrogen first. So look at something. We have 5 carbons here, but you only have 1 here. So the first thing I would do, I would put a 5 in front of this carbon. Alright? Then we look at the hydrogen. We have 12 hydrogen here, but you only have 2 here. So therefore, in order for me to get 12, I need to put 6 across here. Alright? Now, for sure, the oxygen is not balanced. You only have 2 here, but on the right hand side, you have 5 2s at 10 and 6. You have 16. Right? So because you have 16, all we need to do now is to put an 8 in front of this. Alright? So, you all follow me here? First thing to do, balance your carbon, then balance your hydrogen, and then balance the oxygen. Right? Let's make sure this is correct. So 5, 5, so 12, so that is 6, 10 and 6, 16. Alright, so this seems correct here. So you all need to be able, any alkane that they give you in the exam, you should be able to write an equation for the reaction, right? The products will always be carbon dioxide and water, always. Okay. Now you need to know that this reaction here is actually exothermic, right? So it's an exothermic reaction, meaning that energy is being produced, right? A lot of heat energy is coming out of this reaction, right? So this is the first equation or the first reaction you all need to know. The second one is the reaction with halogens. Alright? So here's what you need to know. When I react, let me start off with something simple. Let's say we have CH4 as the first member of the homologous series plus Cl2 gas produces CH3 Cl gas plus HCl gas. Right? So look at what is happening here. When I react methane with chlorine gas, I am going to get this compound here and HCl. Now the type of reaction that is taking place, so you will be asked that type of reaction. So the type of reaction undergone by alkenes are substitution reactions. You need to know that. Substitution. Right? So the type of reaction that alkenes undergo is substitution. You need to know that. You also need to know the conditions for this reaction. In order for chlorine to react with methane, we need UV light. This is important. You are getting marks for your reaction conditions. In order for this reaction to take place, you need ultraviolet light. Right? Now, I'm not going too much into the what we call the mechanism for the reaction, right? That is more at the cape level. So all you need to know is that we require UV light in order for the reaction to take place, right? Long story short, the UV light splits the chlorine molecules to produce what we call free radicals, right? And the reaction is basically a chain reaction, right? You have several steps. It's called initiation, propagation, and then termination, right? But that's for keep. Don't worry about that. So all you need to know is that UV light is required. And it's a substitution reaction. Now, let me draw this so you'll see exactly what's happening, right? So we have CH4, which looks like this. And then you're reacting that with Cl2 with UV light. But look at the product that I'm getting. Plus HCl. So what has happened is that, use a different color here again. So what has happened is that one of the hydrogen has been replaced or substituted with a chlorine atom. So that hydrogen that came out eventually formed HCl, right? So this is the reaction that is taking place. It's a substitution reaction. So please make sure you know that alkanes undergo substitution reactions. Ultraviolet light is required. My product, in this case, we get an HCl being produced, right? So I've seen them ask that in the past paper questions. Some students are not sure what the products are. So the products are, you're going to get monochloromethane, that's one, that's this compound here, and HCl. But the thing is, that's not the only product you could get. You can have multiple substitution reactions taking place, right? So this here is just one of the products we can get. We can get other products as well, right? And let me show you what the other products could be. So from that same reaction, we can have something like, these are the possible products you can get. So instead of having just one hydrogen atom replaced, you can have this. This is another product. Our next product we can get is this. Cl, 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 H as the next product. We can also get all the hydrogens being replaced by Cl. Right? So sometimes, so this here, this can be, where is it? Right, so you can This is one possible reaction, right? But you can also get a reaction that looks like this. It can be CH4 gas plus Cl2 gas producing, and this in this particular scenario we'll be substituting all of them, all the hydrogen. CCl4, which is a liquid actually, plus 4HCl. Right? And this should be 4 here. Right? So this could be an overall reaction. Right? Just keep in mind that you can have multiple substitutions. Right? So there are only two reactions you really need to know for alkanes, and that is combustion with oxygen, and the second one is the reaction with halogens. Right? You will get a similar reaction if you react with Br2 as well. Okay, so that's all we really need to know for alkanes. Let's move on to alkenes now. Now, first thing, the general formula for an alkene is CnH2n, right? You need to know that. The functional group present is the double bond. That is the functional group present in an alkene, right? Now, we said just now that alkenes, they undergo substitution reactions. Well, here's the thing. Alkenes, they undergo what we call addition reactions. There are lots of examination questions where they compare alkenes and alkenes, right? So, let's look at the members of the alkene homologous series. Now, the first member of the alkene homologous series is this. The formula for this is C2H4, and the name is ETENE, right? Now, obviously, to be an alkene, you must have a double bond present. There is no alkene that has one carbon atom, right? I've seen this as an exam question already. They wanted to know, why is there no alkene with one carbon atom? If we know the functional group in the alkene is the C double bond, right? Then you need two carbon atoms in order for that to happen. So it's not possible if you only have one carbon atom present. The next one, let's say we have this compound here, which is this. Right, so the formula for this one is C3H6, right? Now, here's the thing. When you are naming your alkenes, you need to be careful, right? Now, the reason why I'm telling you you need to be careful is because CXC wants you to state the position of the double bond. So, in order to do that, what we do, we number or we find the longest carbon chain, right? Which in this case here, this is our longest carbon chain, right? This is our longest carbon chain. So this is carbon 1, this is carbon 2, and this is carbon 3, right? So the name of this compound here, because the double bond is located between the first and the second carbon, right? We're going to say this compound is 1-prop, because we have 3 carbon atoms, 1-propene, or it is called prop 1E, right? So you need to state the position of the double bond, right? I've seen where CXC, they don't want to give you the mark because you said propene, but you need to say 1-propene or prop 1E, right? So that's the second member of the homologous series. let's look at the next one. Next one is going to be this. So again, the formula for this one here is C4H8, right? Now, like I said, you need to state the position of the double bond. So we find the longest carbon chain, which is this big long piece here, as this. All right, we're going to number it. So we go 1, 2, 3, 4, right? So we notice that the double bond is between my first and second carbon atom, right? So the name of this compound is going to be 1-butene, 1-butene, or it's going to be but-1-ene. So it's going to be but-1-e, right? Now notice we didn't name the compound 2-butene or but-2-ene, right? Even though the double bond is between the first and the second carbon atom, the number that we choose is the smaller of the two numbers, right? So it's but-1-ene and 1-butene. So any one of those names will be acceptable, right? You cannot just put butene, right? CSEC may not give you the answer for that, give you the mark for that, sorry. Alright, so that is, so we can continue, right? Basically we could keep drawing more members of the homologous series, alright? But let's go straight to the reactions, which is what is important. So like I told you, alkenes undergo addition reactions. So my first, so this is reactions. Right, so first one, reaction with oxygen. Right, so reaction with oxygen gas. So alkenes, there's alkenes we're talking about here. Don't mix up the two. Alkenes burn with a smoky yellow flame. Right? So alkenes, they burn with a smoky yellow flame, which is different from the alkanes. We said that the alkanes burn with a clean blue flame, right? Now please, I'm going to reiterate this. Examination questions are going to come and they're going to ask you, how do we distinguish between an alkane and an alkene? Please do not put an alkane burns with a clean blue flame and an alkene burns with a smoky flame. You will get 0, right? That is not what they want for the answer. I'll give you the answer in a little bit. But do not tell them the color of the smoke is going to differentiate between the two. I'm telling you from now, you will get 0 marks for that, right? So alkenes, they burn in oxygen with a smoky yellow flame, right? So let's say we had, I'll give you an example. In the exam, they can give you any one. So let's say C2H4, right? Right? Plus O2, gas. Again, when we burn an alkene, we're going to get CO2 and water, right? Just like in the previous one for the alkane. So you're going to get CO2 gas and H2O gas. Alright, now in order to balance this equation, we're going to have to put, you have 2 carbons on the left side, so you need to put a 2 here. You have 4 hydrogen, so you're going to put a 2 here, and that's 2 2s are 4 and 2 6, so therefore we need to put a 3 here. Right? In the exam, they can give you any alkane. They can give you something that has 5 carbon atoms and tell you to write an equation for it. The key thing to remember is that carbon dioxide gas is being produced and water is also being produced, right? And again, this reaction is also exothermic, which means energy is being produced, right? Now, let's move on to the second reaction. So the second reaction, let's say I have something like this. Now, sometimes it's easier to visualize these things when we draw the diagram. So hydrogen, this is ethene plus H2 gas, all right? Produces now this type of reaction here is called an addition reaction, right? What is happening is that hydrogen atoms are being added across the double bond, right? Now here's what you all need to know. You all need to know the conditions for this reaction. So this is, you need a nickel catalyst. So you need a nickel catalyst, right? And the temperature in this case here is 180 degrees, right? Or 150. Let's go with the 150. Right? So nickel catalyst, 150 degrees, 180 degrees, no matter, right? And 5 atmospheres, right? Now, what you get in your marks for in organic chemistry is to be able to state the conditions for reactions, you know. So this compound here, this is ETHENE, right? I'm reacting it with hydrogen gas, and what I'm getting here is ethane. So this reaction here is how we convert an alkene into an alkane. We use a nickel catalyst, 150 degrees Celsius and 5 atmosphere, right? So you need to know that. Now, this type of reaction here is called an addition reaction, right? And basically that's how we produce margarine. Basically we add more hydrogen. So let me just tell you something one time. So this, because you have double bonds present, those compounds that have double bond present are called unsaturated compounds, right? So when we see a double bond present, we say it is unsaturated. But when we have no double bonds present, we say that it is saturated. So you know when you're watching the labels on some products, you're going to see saturated fat or unsaturated fat. So saturated fat means you have only single bonds present, but if it's unsaturated, it has double bonds present, right? So this is one reaction that you need to know. We need to know we're using a nickel catalyst, 150 degrees C, 5 atmospheres, right? Let's look at our next reaction. So this next reaction is reaction with halogens. So reaction with halogens, right? And when we say halogens, we're talking about things like Br2, right? So in this case, what is happening here is that we start off with so we have this plus Br2. What is going to happen is that the bromine is going to add itself across the double bond, right? And the name of this compound here is 1,2-dibromo ethane, right? 1,2. Let me just 1,2-di. Yes, I know the name looks a little confusing and it's long, but here's why. So the longest carbon atom is this, right? Carbon chain, sorry. So you have one here, you have two here, right? So you have Br attached to the first carbon atom, and you also have Br attached to the second one. So this is what we are saying. We have 1, 2, and it's 2 bromine atoms, so that's why you see dibromo, and the root name is ethane, right? So it's 1, 2 dibromoethane. Now, for this particular reaction, right, what is happening here is that you have a color change taking place. So the bromine, right, as this, goes from reddish brown to colorless. I want you to remember something. Anytime in the chemistry exam they ask you what is observed, whenever they ask you for something that is observed, we're looking for something that we see, that we smell, or we hear, right? We're using our senses, right? That is observations we're talking about here. So bromine is reddish brown, but in this particular reaction, what is going to happen is that the bromine is going to be decolorized. So it's going to go from reddish brown to colorless. So remember, I said in the exam, they're going to ask you, how do we test or differentiate between an alkene and an alkene? You see, this particular reaction, this is one of those reactions that can be used to differentiate between an alkene and an alkene. The alkene, you'll get this reaction. You'll get decolorization of bromine, or we're going from reddish brown to colorless. In the case of an alkane, this reaction does not take place, right? So this is one reaction that we can use to differentiate between an alkane and an alkene. So next reaction. So the next reaction we need to know is this one, which is important. So if I have plus H2O gas, so I'm reacting the alkene with steam. I'm going to get so this is how we convert an alkene into an alcohol, right? We're going to react with steam, and this is what the product is going to be. Now, here's the thing. When you get a question like this and they ask you for the conditions, I've seen them ask a question like this and give you 5 marks just for doing this. You have to write the equation and you just state the conditions, right? Now, you're in Form 5, right? I remember when I was in Form 5, I had to learn this off. I remember learning off these things, right? So here's what the conditions that we need. So the first thing is a phosphoric 5 acid catalyst, which is H3PO4. Hold on. So it's H3PO4 catalyst. That's 1. Just for stating that, you get 1 marker. The next thing, you need to state the pressure, which is 70 atmospheres. That's our next mark. And the last thing is to say 300 degrees Celsius. You are getting marks for these conditions. If you get a question like this in the exam, it's 5 marks, you know. 1 mark for saying H3PO4 catalyst, the second mark for saying 70 atmospheres, and the third mark is for saying 300 degrees Celsius. Please learn your reaction conditions, right? Cannot stress that enough. So this is my reaction with steam. There's a next reaction that we need to know, which is also another test that we can use to differentiate between an alkene and an alkene. So this equation looks like this. So we have ethene again, plus H2O plus O in a square bracket. I'll tell you what that means just now. What we're going to get here is something called in this case here we're using H plus slash KMNO4. So here's what we're doing here. So when we react an alkene with acidified KMNO4, right? This is how we write the equation. Acidified potassium manganate 7 is an oxidizing agent, right? So when we write equations with an oxidizing agent, we usually put an O in a square bracket, right? So this is what how it looks. The name of this, the product that we're going to get, it is called ethane 1,2-diol, right? It's called now the OL tells us it's an alcohol, and you have two OH here. You have this one and you have this one, so it's a diol, right? This is something you just need to learn off. It's if an organic compound has two OH groups present, it's called a diol, right? So when I react an alkene with acidified potassium manganate 7, you need to know what is observed, right? So my observation, the observation in this case here is that now potassium manganate 7 is a popular reagent that we use in chemistry, right? Especially at your level. So you need to know acidified potassium manganate 7, it is purple, right? It's an oxidizing agent. Now in this particular reaction, what is going to happen is that the KMNO4 changes from purple to colorless, right? That's what's happening. So that's my observation. It's changing from purple to colorless, right? So this particular reaction here is another test we can use to differentiate between an alkane and an alkene, right? The alkene is going to give you this color change, but not the alkene, all right? So you need to be able to write this equation. You need to know the color change, right? Just for your knowledge, because under oxidation and reduction, you need to know why we get in this color change. Acidified potassium manganate 7 is an oxidizing agent. Because it is acting as an oxidizing agent, it is going to be reduced. The purple color, right, has to do with the manganese ion. The manganese ion has an oxidation state of +7. That is why it is purple. When it is reduced, it changes to oxidation state +2, right? So that is why you're going from purple to colorless. You need to know this, right? And the last reaction that we need to know, which we'll come back to when we do, so the last one is called polymerization. Right? Now, alkenes, because of the presence of the double bond, so like this. We're gonna have to come back to this, right? But for now, we have two types of polymerization, right? Something called addition and condensation. But alkenes undergo addition polymerization, right? So what happens is that if we take a whole set of alkene molecules, what is going to happen is that they're going to combine to give us what we call a polymer, which is a long chain macromolecule that's going to look like this. All right? We can't draw the formula for it, so we do like a general formula. All right? Alright, so that's it for the reactions of alkenes. So, like I said, you need to be able to distinguish between an alkane and an alkene, right? So, let's say we have, make sure you know this. So, you have an alkene and we have an alkene. The first test is to so one of the tests is to add Br2 in CCl4, right? That's one test. Add bromine in CCl4, right? In the case of the alkane, we get no reaction, so no color change, right? In the case of the alkene, you get decolorization of the bromine. So in this case, you're going to get rapid decolorization of the bromine. So in this case, the color change is from reddish brown to colorless. You need to know the color change. So you go from reddish brown to colorless, right? So the alkene will give us a color change, but the alkene will not. And the second test is to add acidified potassium manganate 7. Right? Again, no color change, so the solution just stays purple. Right? In the case of this one here, what happened is that you have rapid decolorization. And what is happening is that we're going from purple to colorless. Right? So that is how we differentiate between an alkene and an alkene. Right? So we either use bromine in CCl4, or sometimes you might see bromine water is added. Right? You're gonna get a color change with the alkene, or we could add acidified potassium manganate 7. Again, we can get a color change. All right. So that's it for alkanes and alkenes. Those are the reactions that you need to know. And you also need to be able to distinguish between the two. So the next homologous series is alcohols. So the general formula for an alcohol is CnH2n plus 1 OH, right? So let's draw the first few members. So the first member was going to be this one. Right? In this case here, the formula is CH3OH, right? And this is methanol. The next one here is so this is ethanol, right? The next one is now. Just like with the alkanes, we need to state the position of the double bond. In the case of alcohols, what we have to do is to state the position of the OH group, right? So the formula for this here is CH3CH2 CH2OH, right? Now the name of this compound here is called 1-propanol. So it's 1-propanol or prop. Right? This is the name of this compound here. We need to state the position of the OH group. So what you would do, you would identify the longest carbon chain, right, which is 3 carbons, and you need to number them. But I'm going to number it where I'm going to put 1, 2. So I'm putting the OH on the first carbon basically, right? So that's why I'm getting 1-propanol or propan-1-ol, right? When I look at isomers in a little bit, we will talk more about that, right? So these are just the first 3 members of the alcohol group. Now, let's talk about something here. So the alcohol group, let's say I'm talking about ethanol, right? I need you all to understand something one time. Now the alcohol group has, see this OH group here? This OH group so this OH group, right, is polar, right? So this piece here, this is polar, right? Now the reason why that is polar is that oxygen, so let me draw this over here. So this is oxygen and this is hydrogen. Now oxygen is more electronegative than hydrogen. So what happens is that, remember, a bond is made up of a pair of electrons. So if oxygen is more electronegative than hydrogen, what happens is that that bond pair electron is shifted closer to the oxygen atom. What that means is that that oxygen atom has a small negative charge on it. And because of that shift, the hydrogen has a small positive charge. So the OH group in an alcohol is polar. Now, let's look at what a water molecule looks like. A water molecule looks like this. Right? Again, oxygen is more electronegative than hydrogen, so it pulls electron pair closer to itself on both of these here. So what is happening is that the oxygen has a delta negative charge, the hydrogen has a delta positive charge, and the hydrogen also have a delta positive charge. So what is happening here is that the water molecule itself, so this water molecule is also polar, right? Now, what happens is that, see this H, when you mix an alcohol with water, it is going to be soluble, it's going to dissolve in the water or mix with the water. And the reason for that, so solubility we're talking about here, right? So in the case of the alcohol, the OH group forms bonds with the water molecules. Right? So the OH group in the alcohol is able to form bonds with the water molecules. Right? What we form there is what we call hydrogen bonds. Right? But all you all need to know, you need to know that the OH group is polar. You need to know that water molecules are also polar, and therefore the alcohol, they form bonds with the water molecules, right? And that's why they are soluble. So that's something you need to know. Sometimes they ask about solubility, and for 2 marks they come and they ask you, explain why, right? So it's because of the polar OH group, and water molecules are also polar. So let me just pause for a second and Everybody okay? Alright, cool. So I'm trying to run through the organic material, right, as fast as I can, because what we're going to do after, I'm going to go through as much of the organic past paper questions that we can get our hands on, right? This is something that you seriously need to pay attention to. You can get a lot of marks if you know your organic chemistry well, right? This is one thing you're sure is going to come in the exam. I mean, every year you can guess and say, well, a question is going to come on rates of reactions or oxidation reduction. You're really guessing to kind of figure out what is coming. But in the case of this, I am certain it's coming. It comes every year, right? You have no choice. It's going to come. So let's look at the reactions of alcohols, right? So reactions. Alright, so my reactions of alcohols. The first one is burning in air, basically, right? So the first one is burning in oxygen, right? So alcohols, they burn with a clear blue flame, right? So they burn with a clear blue flame, right? Alcohols do that, right? So let's burn ethanol, sorry. So ethanol, the formula for ethanol could be C2H5OH, right? Liquid plus O2 gas. Just like with the alkanes and alkenes, what happens is that we're going to get CO2 gas and H2O liquid, right? If we balance this will be 2, this should be 3, and this should be 3, right? So when I burn ethanol and oxygen, you're going to get CO2 and water, right? I know some of you all probably try this at home. Take a little bit of alcohol, put it in a little a cap, and try to light it a fire. You barely see it, right? Because the flame is so clean that you barely see it's lighting, right? I'm not telling you go and do this at home, So when you burn ethanol in oxygen, you're going to get carbon dioxide and water. This reaction is very exothermic, right? And yeah, so let's do the second one now. So the next one is reaction with sodium. Alright, so in the case of sodium, this is what happens. So we have C2H5OH as ethanol. Now notice I'm giving you examples here, right? In the exam, I mean, they could give you any alcohol, but the equation is going to be similar. Plus Na solid. We know that sodium is a metal. It's a very reactive metal, right? And what we're going to get is C2H5O minus Na plus. And I'm doing this to show you that it's an ionic compound that we get in, plus H2 gas. Hydrogen gas is going to come out here. And we need to balance this. So how do we balance this? We need to put a 2 here, a 2 here, and a 2 here. That should balance it there. Yeah. Now, the name of this compound here that we get, right? It's called sodium ethoxide, right? It's an ionic compound, right? And we also get in hydrogen gas produced, right? Now, draw it this way as well, because in the exam they can ask you to write the equation or draw it, right? Plus 2 Ne, so this is 2, and you're producing right. So this is what the sodium ethoxide looks like. So in the exam you can write any one of the equations here, right? So just know that the product is ionic. Right, so that's the second reaction we need to know for alcohols, right? Just give me a sec here. I can get some more blank pages. Alright, so my next reaction here, which is the third one we're going to talk about. The third one, right, is what we're going to call dehydration. Right? So this reaction is called a dehydration reaction, and what is happening here is that, let me draw it like this so you'll understand better. So if we have an alcohol, I'm going to put the OH here, right, to show you what's actually happening. Now for this one you need to know the conditions, right? So basically we're heating the alcohol and we're using concentrated sulfuric acid. So we're using concentrated CuNC H2SO4, right? And the temperature we're using is about 170 degrees Celsius, right? So these reaction conditions, we heat into about 170 degrees and we're using concentrated sulfuric acid, right? And what is going to happen is that, let me use a different color here. So this OH, this H and this OH here is going to come out, right? It's going to come out, and what's going to happen is that you're going to end up with this. So my product in this case is going to be H2, right? So really and truly, what we are moving from here, you are moving from, in this case here, ethanol, and we're going to an alkene, which is ethene. Alright, so this is what we call a dehydration reaction, right? You need to make sure you know your conditions. It's excess concentrated sulfuric acid, 170 degrees Celsius, right? The next reaction here is oxidation. Right? Now, we can have oxidation taking place, let's say, two ways we can do this. We can use acidified KMNO4, right? We met this just now. This is an oxidizing agent. Or we can use acidified K2Cr2O7, right? That is potassium dichromate 6, right? You need to know these reagents. These are important reagents. You have to know them. So the first one is acidified potassium manganate 7, and the second one is acidified potassium dichromate 6, right? Now, these two are what we call oxidizing agents. Now, if you warm an alcohol with an oxidizing agent, it is going to be oxidized, right? But the product that we get is an acid. So, an alcohol, right, plus an oxidizing agent, right, what it'll give me is a carboxylic acid. So, take for example, let's use ethanol as our example again, right? So, if I use this, plus, now because it's an oxidizing agent, we're going to have to write, we're going to do this. Remember how we're going to put an O, capital O, in square brackets. And what you're going to get as your product is an acid. So you're going to get this. And plus, you're going to get water being produced as well, right? So this is H2O, and this should be a 2 here, right? So this is the reaction that's going to take place when we warm. So all you need to do is to warm with the oxidizing agent. Right? KMNO4 is much stronger than acidified potassium dichromate 6. So the KMNO4, as soon as you mix it, the reaction will take place. In the case of the chromate, you're going to have to warm it up. Now, as we're talking about this one time, so there's something called the breathalyzer test. Right, y'all need to know about this, and especially in Trinidad we do breathalyzer testing. So what's going to happen, here's how this works. So you have somebody, they have alcohol in their breath, right? They're going to breathe inside of the machine. In this case here, so this is alcohol, right? They're going to blow inside of it. Then what we have here is potassium dichromate 6 crystals, right? And this is acidified, right? So you have crystals here that have some acid on top of it, right? And when you blow into this machine, what is happening is that the crystals are normally orange, right? You'll need to be able to explain the breathalyzer test. So originally, crystals are going to be orange. If the person has alcohol on their breath, what is going to happen is that you're going to get a color change from orange to green, right? Now, why is that? So the element that is causing this change for us is chromium, right? So the chromium, that's Cr, it changes from oxidation state +6 to +3, right? So make sure we have it clear. So the K2Cr2O7, right, oxidizes the alcohol. So the K2Cr2O7 oxidizes the alcohol, And what happened is that the K2Cr2O7, because it's acting as an oxidizing agent, it is reduced. But in this process here, we are changing from oxidation state +6 to +3, right? That's a decrease in oxidation number. That's a decrease in oxidation number. Oxidation number. So therefore, this is a reduction taking place here, right? So make sure you understand how the breathalyzer test works. So in the device itself, we have acidified potassium dichromate crystals. When you breathe into it, if there's alcohol in your breath, the alcohol is going to be oxidized, right? During that process, because the acidified potassium dichromate 6 is acting as an oxidizing agent, it is, wait, I just realized there shouldn't be a, there's not 7 here, there's 6. Yeah, so the acidified potassium dichromate 6 is acting as an oxidizing agent. If it's acting as an oxidizing agent, it is going to be reduced. So the chromium inside of it changes from oxidation state +6 to +3. The +6 is orange and the +3 is green, right? That's why we get in that color change. So usually they will ask you to explain the chemistry of the breathalyzer test. That is what they want. Now, so this is what reaction we're on here. We're on the 5th reaction now. So the 5th one. So the reaction between alcohols and carboxylic acids, right? So here's what you all need to know. When we have an alcohol plus a carboxylic acid, it's not just any acid. What we're going to get is something called an ester plus water. Alright, notice that this reaction here, I'm putting it as reversible. The forward reaction is called esterification. Esterification. You need to know this. Alright, so esterification is the forward reaction. The reverse reaction is called hydrolysis. This is in the multiple choice paper. So, an alcohol plus an acid gives me an ester, right? I'm going to draw it for you just now. In the exam, when you see the word sweet smelling oily, sweet smelling or oily mixture, right? When you see those words, we're talking about an ester. That's a hint that they give you in the exam. So when we see sweet smelling oily, we're talking about an ester, right? Now, in order for this reaction to take place, right, because it's a reversible reaction, what we do, we heat under reflux, right? So we heat under reflux and we need to use a catalyst, and the catalyst we use in this case is concentrated sulfuric acid. So we heat under reflux and the catalyst we used, so the catalyst is sulfuric acid, H2SO4, right? So these are the conditions. You need to know that. These are my conditions. Sometimes they ask you to draw a diagram to show what we mean by reflux. So this is what reflux looks like. So I can draw this properly here. So just like how I'm sketching this here, you need to be able to sketch it too, huh? Alright, so we have heat, we have acid plus alcohol, right? And basically what we have at the top here, we have what we call a condenser. So the condenser looks like this. Right, so this is water in and this is water out, right? So if they ask you to draw a diagram to show how we heat under reflux, that is what it is basically. So whatever vapor is coming out as we heat in, right, it condenses inside the condenser and it falls back into the mixture, right? But this is essentially what we need to do in order to produce an ester. Now, I'll give you an example as to how we're doing this, right? So let's say let's do let's say we have this. Sometimes some students look at these equations, especially for esterification, and think it's confusing. It could look a little intimidating, but it can be done. Just follow what I'm doing here. So we're starting off with this acid here is called ethanoic acid. Right? Across here we have this is ethanol. Right? Now, what is happening here is that the OH from the acid, so this here, the OH from the acid and the H from the alcohol, right, is going to come out, and what's going to happen, you're going to get this. Now please, when you have to draw diagrams like this, draw the acid first, right? If you draw the acid first, you'll be able to draw the ester pretty easily. Plus H2O, right? And the name, so this compound here is the ester, and this particular ester is called ethyl ethanoate. Now, some students, they get confused as to how we name the acid, how we name the ester. So the second part of the name, so this ethanoate part here, is actually coming from the acid that we are using. And the first part, the ethyl part here, is coming from the alcohol. Alright? You'll need to know that. So when we naming these compounds, especially esters, the first part of the name comes from the alcohol, and the second part comes from the acid. Right? So let me ask you something. So let's say if I used let's say I use propanoic acid, right, and ethanol. I want somebody to tell me what is the name of the ester that I'm going to get. What is the name of the ester that I'm going to get? Somebody saying ethyl propanoate. Is that correct? Ethyl propanoate. So the first part comes from the alcohol, so therefore it's going to be ethyl. And the second part comes from the acid, so it's ethyl propanoate. Propan. How about next one? Let me give you the next one. Butanoic acid and propanol. What's the name of the ester we're gonna get? Alright, so did everybody saying propyl butanoate? That should be correct. So it's propyl butanoate. Right? Alright, so we have to come back to esters when we do carboxylic acids again, right? So there's one more reaction that you all need to know for alcohols, and that is fermentation. Hold on. Right? So the next reaction we need to know is fermentation. So we can produce alcohol, well, basically ethanol, right, by fermenting some sugary products, right? So now you have to be careful with this question. I've seen this question come for like 7 marks already in the exam, right? And you need to be careful in terms of what you're saying. So the first thing you need to know an equation for the reaction. So the equation for the reaction, we're going to start off with glucose, which is C6H12O6, right? Aqueous. And what we're going to get is C2H5OH, which is the alcohol. So you're going to get C2H5OH, right? Aqueous plus CO2. Right? And you have to balance this, so we need to put a 2 here and a 2 here. So you all need to know this equation. Chances are you'll get like 2 marks for this, right? So here's what you need to see in order to get your marks, right? So the first thing, we need some kind of sugary substrate, right? Example. We don't have grapes in Trinidad, but you can use grapes. People use rice, hibiscus, right? So basically we need some kind of starchy substance to start off with, right? And we need yeast, which will provide an enzyme called zymase. Right, so it's an enzyme. So we need yeast here, right? So we need an enzyme. We need yeast that will supply the enzyme for us, right? You all please need to say that water is required. right? Temperature has to be less than 40. Right? You also need to say, what am I missing? Sugary, need yeast, water. You need to indicate that the yeast, the enzymes in yeast, breaks down the sugar anaerobically. Right? These are things you're saying to get your marks here. This is 7 marks, you know. Anaerobically, and anaerobically means no oxygen. Right? So some of you doing bio, right? Anaerobic respiration, no oxygen is required. So enzymes in the yeast break down the sugar anaerobically to produce ethanol. Ethanol and carbon dioxide. Right? Those are the two things that we produce. Now, here's what's happening here now. When the concentration of the alcohol reaches about 14%, what happens is that the enzymes become denatured. Right? So let's go on to the next page here. So when the concentration of alcohol reaches about 14%, the reaction stops. Right? So why does the reaction stops? Now please in the exam don't tell the people that the enzymes are killed or they, that's not what they're looking for. The enzymes are denatured. That's the word they're looking for. D-N-A-T-U-R-E-D. Right? Meaning that they stop working. Then dead, they just stop working. Right? So therefore the alcohol content or the alcohol concentration that you get is 14% by volume. Right? But if you want to produce alcohol of a higher concentration, you're going to have to do simple distillation. Distillation is required, is needed to produce higher concentration of alcohol. Right? So we use distillation in order to produce higher concentration of alcohol. Alright? And that basically takes us through alkanes, alkenes, and alcohols. Right? Which is a fairly big chunk of what you need to know. Right? So I'm going to use this opportunity to pause right here. Right? And those students who are in my class, what I will ask you all to do is, when you log into the website, you're going to have you're going to go under organic chemistry, and there are basically 3 different quizzes that I would like you all to do. Right? And that will be, just give me a second, let me just tell you what they are. Right, so the quizzes that I would like you all to do would be the quiz on alkanes and alkenes, alcohols. Yeah, so basically it's 2 quizzes that I want you all to do, right? That'll be, let me show you what I'm talking about. Alright, so when you log in, you're going to go to right, so you're going to look for these 2 quizzes when you log into the website. Right, and that'll be it for today. All right, so please review. In order to do well in chemistry, you all need to be reading your notes over and over. It is not something that you can just cram, right? I mean, some people do it, but To really understand what you're doing, you need to keep reading your notes over and over. Alright? So we'll stop there for today. Alright? Until next week, Saturday again. Alright? So you guys take it easy.